Our planet Earth is in constant motion. It spins on its axis, completing one full rotation approximately every 24 hours. This rotation is responsible for the cycle of day and night that we experience. Life on Earth has evolved over billions of years, adapting to this rhythmic cycle of light and darkness. It influences everything from the behavior of animals to the growth patterns of plants. But what would happen if this constant spin were to suddenly cease? Imagine a world where the sun stays fixed in the sky, baking one side of the Earth while the other is plunged into perpetual darkness. This scenario, though seemingly impossible, allows us to explore the crucial role Earth's rotation plays in shaping our world. By understanding the potential consequences of a stationary Earth, we gain a deeper appreciation for the delicate balance that sustains life as we know it. The Earth's rotation isn't just about the cycle of day and night, it also influences global weather patterns, ocean currents, and even the Earth's magnetic field. The centrifugal force generated by the spin causes a slight bulge at the equator, influencing the distribution of land masses and ocean basins. This constant motion is woven into the very fabric of our planet, impacting everything from the air we breathe to the tides that ebb and flow. If the Earth were to stop spinning suddenly, the consequences would be nothing short of catastrophic. The most immediate and dramatic effect would be the sheer inertia of everything on the planet's surface. Just as a passenger on a speeding bus is thrown forward when the bus brakes abruptly, everything on Earth would continue moving eastward at the speed of the Earth's rotation. This means that at the equator, where the rotational speed is the highest, objects, people, cars, and even buildings would be launched eastward at approximately 1,000 miles per hour. The force of this sudden acceleration would be devastating. Imagine entire cities crumbling into rubble as buildings are ripped from their foundations. The landscape would be scarred with the wreckage of our civilization. The oceans, no longer held in place by the centrifugal force of Earth's spin, would surge towards the poles in a colossal tsunami. Coastal regions would be instantly inundated, drowning entire populations and land masses. The sheer volume of water displaced would be unimaginable, reshaping the planet's surface in a matter of hours. The atmosphere, although not directly connected to the Earth's surface, is also influenced by the planet's rotation. The Coriolis effect, caused by the spin, dictates the direction of wind patterns across the globe. If the Earth were to suddenly stop, the atmosphere would continue moving at its previous speed, creating winds of unimaginable ferocity. These winds, traveling at speeds of up to 1,000 miles per hour, would circle the globe, ripping apart everything in their path. Forests would be flattened, mountains eroded, and even the sturdiest structures would be reduced to debris. The very air we breathe would become a weapon of mass destruction. The dust and debris lifted into the atmosphere by these superstorms would further exacerbate the situation. The sun, if visible at all, would appear as a dim orb through a haze of particulate matter. This atmospheric chaos would have a devastating impact on the planet's climate, potentially triggering a global cooling event as sunlight is blocked out. With the Earth no longer rotating, the familiar cycle of day and night would cease to exist. One hemisphere would be subjected to perpetual daylight, while the other would be plunged into an endless night. This dramatic shift in solar radiation would have catastrophic consequences for the planet's climate. On the sun-facing side, temperatures would soar to unimaginable levels. The constant bombardment of solar radiation would scorch the land, evaporating water sources and turning once fertile regions into barren deserts. The oceans, already ravaged by tsunamis, would begin to boil away, filling the atmosphere with scorching steam. The dark side of the Earth would experience a different but equally deadly extreme. Temperatures would plummet to unimaginable lows as the constant heat from the sun is no longer available to warm the surface. The oceans would freeze over, locking vast amounts of water into ice caps that stretch towards the equator. Section 5. The Great Water Shift, Reshaping the Oceans. Now, the centrifugal force generated by the Earth's rotation plays a crucial role in the current distribution of the planet's oceans. Without this force, the oceans would migrate towards the poles, where the gravitational pull is strongest. The result would be a complete reshaping of the Earth's surface. The equatorial regions, once home to vast stretches of ocean, would become a massive interconnected landmass. This new supercontinent would be ringed by two enormous polar oceans, each holding a significant portion of the Earth's water. This dramatic shift in ocean volume and distribution would have profound consequences for the planet's climate. The massive temperature differences between the poles and the equator would drive extreme weather patterns, with superstorms raging across the new supercontinent. Section 6. The Vanishing Shield. Our magnetic field in jeopardy. The Earth's magnetic field, generated by the movement of molten iron in the planet's core, acts as a shield against harmful radiation from the sun and cosmos. This magnetic field is also influenced by the Earth's rotation. If the Earth were to stop spinning, the movement of the molten iron in the core would likely be disrupted. This disruption could weaken or even completely eliminate the Earth's magnetic field, leaving the planet vulnerable to the full force of solar wind and cosmic rays. Without the protection of the magnetic field, the Earth's atmosphere would be bombarded by charged particles, stripping away the ozone layer that protects us from harmful ultraviolet radiation. The surface of the planet would be bathed in sterilizing radiation, making it impossible for most forms of life to survive. Section 7. Life finds a way. The fate of organisms. The combined effects of a sudden stop in Earth's rotation would be nothing short of apocalyptic for life as we know it. The initial inertia, tsunamis and superstorms would wipe out a significant portion of the planet's biomass in a matter of hours. The long-term effects of perpetual day and night, extreme temperatures and the loss of the magnetic field would make survival for most organisms impossible. The once lush and diverse ecosystems of Earth would be reduced to barren wastelands, populated only by the hardiest of extremophiles. However, life is remarkably resilient. It's possible that some organisms, particularly those adapted to extreme environments, could find ways to survive in this new, hostile world. Perhaps deep underground where temperatures are more stable, or in the depths of the newly formed polar oceans, life could find a way to cling on. Section 8. A slow waltz to a standstill. Gradual deceleration. While a sudden stop in the Earth's rotation is highly unlikely, the planet's rotation is actually slowing down very gradually over time. This deceleration is caused by a number of factors, including the gravitational influence of the Moon. If the Earth were to continue slowing down at this gradual pace, the effects would be much less dramatic than a sudden stop, but still significant. Days and nights would gradually get longer, disrupting the delicate balance of ecosystems and potentially leading to more extreme weather patterns. The gradual shift in the length of day and night would also have profound impacts on technology. Satellites, especially those in geostationary orbits, rely on the Earth's rotation to maintain their position. As the planet slows down, these satellites would drift out of position, disrupting communication and navigation systems. Section 9. A spinning miracle. Earth's rotation and our existence. The hypothetical scenario of the Earth stopping its rotation, though terrifying, highlights the crucial role this constant spin plays in our planet's habitability. The cycle of day and night, the distribution of the oceans, the stability of the climate, and even the protection offered by our magnetic field are all intimately connected to the Earth's rotation. We often take this constant spin for granted, but it is a delicate dance that has allowed life to flourish on our planet for billions of years. Understanding the potential consequences of a stationary Earth should fill us with a sense of awe and gratitude for this spinning miracle that makes our existence possible. As we continue to explore the cosmos and search for life beyond our own planet, the story of Earth's rotation serves as a powerful reminder of the delicate balance that governs the universe. It is a balance we must strive to understand and protect, for it is the very foundation upon which our existence rests.